For anyone working on complex models and animations, the new data channel modifier in 3ds Max is a real game changer. But what exactly does it do, and what is a data channel anyway? You can think of a data channel as a slice of information that describes a mesh. For example, there's a data channel for vertex positions, edge creases, face normals, soft selections, and so on. Using the new data channel modifier, you can now pipe this data through a series of transformative controls known as operators, applying a huge variety of effects that dynamically update as you go. At first glance, the data channel modifier might look a bit intimidating. Just look at all those operators. But don't worry. In this tutorial, we'll quickly get you up and running by using the feature to apply a bit of wear and tear to an armchair. The armchair in question has a wooden material assigned to the legs and a red material applied to the upholstery. Visualized using the art renderer, however, it looks like the plastic was just pulled off, so let's make the seat look a bit more like something someone's actually sat on. Now, one way to do this would be to hand paint a texture and apply it directly to the material's base color as a bitmap. Though this is a perfectly acceptable method for detailing a model, note that any changes made later to the object's topology would require revisiting the painted texture. An alternative to this approach is to use a procedural workflow incorporating our new best friend, the data channel modifier. The chief working area of the data channel modifier is called the operator stack. In the stack, data flows from top to bottom where it's processed by each operator. A valid stack must always include an input and an output operator at minimum, but can also contain multiple flows of inputs and outputs. With real upholstery, the raised areas are subjected to the most wear and tear, while creased and sunken areas tend to retain their original color. To replicate this, we'll capture these areas with the curvature input operator. The icons next to the operators indicate the type of data being generated by or flowing through an operator. Since the curvature operator generates per vertex data, we'll need to match it with a vertex output operator. Now you might be thinking that this pancaked result isn't exactly what we were looking for. But if we take a closer look, we can see that for each vertex, the curvature data is replacing the X position. This position output is the default mode for vertex output. We'll change position to vertex color instead. Now, the curvature data of each vertex replaces the X component of the vertex color. As we'll see in a bit, the X component of the vertex color corresponds to the red channel in the vertex color map. Now that we have a valid operator stack, we can adjust its values to get the result we want. When working with the curvature operator, it's always best to start with the scale value to get more predictable results. The display rollout defines how data values are visualized when enable display is active. To preview this effect, shaded colors works best. By default, convex areas are associated with a minimal value of 0. These lower values are represented in blue. The concave areas, meanwhile, have a maximum value of 1 and are displayed in red. The flat regions, on the other hand, are mapped to mid-range values closer to 0.5, so they appear in green. Note that this display mechanism uses map channel 99, so if it ever stops updating, you can always change it manually using the Object Properties dialog. To render this effect, we'll need to use the vertex color being assigned in the output. Press M to open the material editor. Add a vertex color map and set its subchannel to red. We're using the red subchannel here since we only assigned the X component of the vertex color in the data channel modifier. Now add a mix map and another color map to mix a brown color and the original color of the couch. Next, let's use the vertex color map to drive the mix amount and connect the result to the material's base color. When we hit render now, the couch correctly displays the curvature information we had assigned to it from the data channel modifier. However, the worn edges appear too sharp. To fix that, we'll use the smooth operator to spread the curvature out onto the nearby regions of the mesh. Our render is looking much better, but we can still step it up a notch. We'll use the normalize operator to increase the contrast of our effect. Enabling range override gives us direct control over the boundary values. Let's render that out to see what we get. Great. Now the final step is to color the seams. Once again, we'll use a curvature input, but we won't need a smooth or a normalize. The seams are curvier than the couch, so we'll apply a lower strength. Just look at that character, courtesy of the data channel modifier. Best of all, any further adjustments to the geometry will update automatically. No further attention required.